Well, hello. I probably have fixed my volume, so we can actually continue with trying to set these fucking fuse bits because they are very annoying. So, first, let's get back into our environment. Keyboard, software. What was it? I don't know, makefile or something. Yeah. So we needed to set the lock bits, but for some reason it didn't work. So if we are currently trying to do that, we have this command, which should set the fuse bit via the AVR ISP debugger into the 8u2 chip and set the lock bits to, well, FF, so 8 ones. But if we try to do that, let me hook this thing up real quick. Where did I put the wires? Aha, found them. So let's go. Power on. And I need a jumper. 1 second. I have a jumper. Now we connect the reset pin to ground. Eventually. Aha. It's on the wrong way. Now we have connected it, and now we should be able to sudo make set fuse. Put in the password. That wasn't it. We try again. That wasn't it. Wait, do I have caps lock on? Yeah. Yeah, now we're talking. Wait. Sorry. Why did it work now? Why didn't it work yesterday? I hate everything about this. Okay, well, it seems like we set the fuse bits now, so we can actually start coding. USB driver dot S for dot capital S. Now, okay, so this part here is we don't need it as far as I know, because I just copied from the other file. We can just leave it. It doesn't actually affect us. It just sets these arrays at this address. So you can just ignore it. Okay. So we have a kind of, yeah, it's kind of port toggle because we are toggling the fifth bit, I think, number 4, of the B port register on and off, but we forgot to set the port to output mode, so it's just toggling the internal resistor, which is very slow, so you just have a tiny wave. Okay, I can change the stream title now because fuse bits somehow worked. To, I don't know, learning USB with the Atmega8u2. Okay. So fuse bits are done, so could have left that open. And why? So now what we need to do is get the USB to work. So therefore we have the datasheet and we go to the USB controller. And now we read. Okay, yeah, this is the basic layout. So we have the CPU, which we're programming. Then we have the on-chip USB DP which is like a buffer, which we can access from the CPU. And the USB interface actually works very remotely from the CPU. So we just have to set what it's supposed to do, and we just interact with the data we get out of it. So we have the clock. So we get the USB clock, which should be 8 megahertz. We have 16. So we need a PLL prescaler of, divided by 2. So we get the 8 megahertz. Okay, yeah, this is all hardware. This is all hardware. This is hardware. RS22, okay. Design guidelines, okay, yeah. Oh, we apparently need 22 ohms of serial resistors on the USB data lines. Traces from the input. Did I do that? Wait. I basically stole everything from the Arduino, so I'm just gonna Arduino schematic. Yeah, this should be it. Images. So yeah, this is basically the same one. Where is the USB? There it is. Okay, there are 2 resistors. Don't know why they are there. That I don't think I did. I might need to cut open my PCB, or it will fry the chip. We will see. So let's see. Open KiCad, open the schematic, view the schematic. Yep, that is nowhere to be seen. Or is it? Wait, they changed it. Where do I? Okay, this is the button. Yep, no 22 ohm resistors. That is disappointing. Well, I'm gonna try it without. Oh wait, no, we're just gonna Google why they are there. USB data line lines, 22 ohm resistors. Why are you there? Yes. I wonder if these resistors, there's an S missing, my friend, are even necessary, since the USB ports should have some isolation built in, correct? I think the USB line is a transmission line, so it can have noise signals that keep power by having the voltage and current out of phase. Wait, what? So it can have noise signals, yes, that keep power. How do you keep power? By having voltage and current out of phase and bouncing from end to end. But when the noise hits the resistor, it can only pass through with voltage and current in phase and suffers real power loss, thus dampening out the noise. So they are noise filters. Okay, yeah, I'm gonna make a note of that one. Let's just make a note document here. Notes.txt. Vim notes.txt. Yeah, would be preferable to actually type a command. So we need to add 22 ohm resistors on USB data lines as filter. Okay, I'm gonna try it without. It should work. If not, I'm just gonna use a smaller cable, but I will add them into the actual schematic, but not today. Okay, yes. So we're just gonna ignore that. Okay, we're just gonna assume the hardware is correct. Memory management. Yes, okay, cool. Yeah, registers, that's what I want. USB con. USB general control registers. Why is it so small? Mobile users can't read that. Okay. Bit 7, USB-E, USB macro enable bit. Writing this bit to 1 enables the USB controller and the USB data buffers D plus and D minus. Clearing And this bit disables the USB controller and buffers. So we need this to enable it. Got it. This bit is reserved. Okay, yeah. Freeze clock. Writing this bit to 1 disables the internal clock for the. Okay, this is to freeze this. We need 0 to resume. What? Well, oh, this is another one. I thought, what? There is no other register here. Okay, so there's somewhere a flow of how to just basically start and accept one request, just so we can get an acknowledge working. Operating modes. No, design guidelines. This is hardware. Okay, we are going to go to the operating modes. Maybe there is something here. Features. Overview. USB power. Yes, pad suspend, read write. USB software, register description. Wait, software? Depending on the USB operating mode, the software should perform some of the following operations. Power on USB interface. So this is what we need to do to power it on. Funny thing is we will attach this before we actually use this, because wait, didn't it say something about this? Nah, I don't care. I just want to power on. Configure the PLL. Enable the PLL. Check PLL log. After we enabled everything, yeah, that seems like a step 1 to me, but sure thing, buddy. Enable USB interface, configure it. Yeah, I just want to do the endpoint 0. I don't know if it's shown on Wikipedia. Do we have something about endpoints here? Endpoints. Okay, yeah, no, apparently not. Really? Okay, so how endpoints work is basically you have endpoint 0, which is for controlling the device. And then you can have, I don't know if there's a limit, but you can have in endpoints and out endpoints. Basically how many you want. I don't think there's a limit, but it's basically the it's like ports with Ethernet, only that these ports have one specific function, like write or read. And you can say this port is if, I don't know, if we're working with the keyboard, like I'm doing this port, this endpoint just sends if there is a key rollover happening, and this endpoint does everything else. And maybe the first endpoint, I don't know if it's this one, but I think it's a different one where you set the what's it called? Global items? No, this is not. This is, yeah, genau, the report descriptors, where you say what you are actually sending in your data, or what your data means, how it's supposed to be interpreted. So first we will have to configure the PLL interface. Okay. Where do I do that? Register description. Software output enable register. No. Regulator control register? No. Do we have a separate PLL chapter, or that's not looking too good, my friends. Oh, we have a lot. Bootloader support, debug via memory program, electrical characteristics, typical character, register, avatar. The avatar? Okay. Nice to know, I guess. Pin configurations, overview, resources, code example. ADS CPU core. The PLL isn't part of the core. That would be stupid. Memories, it's not part of that. Clocks and clock operations. Ah, PLL. That's what I'm looking for. PLL is used to generate internal high frequency. Yes. PLL input is generated from an external low frequency. Yes. The internal PLL generates a clock frequency that is 6 times multiplied from a nominally 8 megahertz input. So we need to get an 8 megahertz input. We have a 16 megahertz crystal. Okay. So we have the crystal. We have a clock select. We already set that with the fuse bits. So it should. You know what? Let me check that. Let me check that one. If it's actually using it. So we're gonna USB driver.s. We are gonna copy this one. Gonna paste it up here. We're gonna copy this one too. I'm gonna paste it here. And whoopsie, that was not the button. So we want it to be the opposite of 1.0. So we will have to set it to not F, but E, F. Yeah, that seems about right. And this should be port B. So now it should be set to output mode, if I'm not mistaken. So we're gonna make send. There was an error. Oh yeah, sudo make send. You know what? I'm gonna just sudo yeah 777. Why not? It will reset after I plug it in again after restart, so doesn't really matter anyways. Anyway, def ttyamc0. Now I should just make send. Yes, it works. So proud. So I'm gonna take my oscilloscope and I'm gonna check if it works. Wait, I need ground. Oh no. Oh, I have breadboard. This is easy. Just plug this in here. Take this cable, plug this in here, and this in here. Okay. Now I take this cable, attach it to the ground clamp, turn on my oscilloscope. I need to work out a solution for you guys to see this. Maybe I can use my phone as a camera or something. Okay, not a lot happening, but we can. That was the wrong button. This is the right button. So we're gonna quickly check where my port B is. This was it, right? So okay, it's not toggling. Okay, yeah, that's because the trigger is literally on the wrong one. It is still not toggling. This is a bit concerning. So, what could be the issue? Did I mess up port B? Something like that. What's going on here? Where are your pin configurations? Right now, that's the wrong one. I/O ports here. I/O ports, register description, port B. Ah, it's directly port B. Is there no A? My dudes. Okay. Yeah, data register. Okay, where do I have a description for it? Somewhere up here, probably. But this alternate port functions, yeah, I should probably just go here. Port B. So I'm gonna use the output. I set it to 0. So it's on output mode. Why is it on input mode? Output low. Output high. Oh, they changed the names. So port B sets low and high. What did I do here? Yes, this is not right. Yes. Port B. That did not work. What? Okay. Port B. This should toggle, if I'm not mistaken. So no pull up. That's important. So port B is toggling. That's correct. But we need DD. DDB. Is DDB a register? No, DDRB. Why is it called DDB? I don't know. Okay, sure. I'm gonna change this one to DDRB. Now it should work. Wait, no. This is supposed to be 1 for output, isn't it? Who designed this shit? Yeah, 1 for output. You know what? Just gonna cut this out here and paste it down here. And we're gonna write. We're gonna make send. And now everything should work. Please. Guys, it's not toggling. Why isn't it toggling? My friend, why are you not working? Okay. This is disappointing. That is very weird. Something wrong with the fuse bits, maybe. Shouldn't be. So you're 1, 1. This is weirding me out. What is happening? Am I measuring the wrong port? That would be very funny. Up and here. Nope, wrong one. Here. So I set this one, pin 18. I am measuring at pin 18. What are you doing? Okay, this is weird. Gonna measure the clock. Yeah, I didn't think that was possible. Not like this. This is concerning. Are the fuse bits to blame? I messed something up there. Shouldn't have. Oh no. AVR fuse calculator. We Atmega8u2. So fuse bits. I don't think I can mess a lot up here. Okay, why are you dividing the clock by 8? What was the signal I was... Why isn't it working now? This should... Okay, I don't know what's going on. Oh, sorry. Could it be the fuse bits? Or what is the alternative function of that specific port? Maybe there is some wacky nonsense going on. Alternate port functions. Port pin 024. Timer, counter, 1, clock input or pin change, interrupt. Every one of these has a pin change interrupt. But I don't think that's doing anything. Or I would be very surprised. Yeah, sure. Am I measuring wrong? Let's just try again. I'm just gonna write it again. First I'm gonna compile it again. Then I'm gonna send it again. And then I'm going to measure again. I don't see any toggling. And reset pin is also high, so that shouldn't be the issue. D9 F4. Is that correct? That should be what I wanted. Isn't it? D9. Wait, I want FF, not F4. What is F4? Oh, E fuse. Never mind. I didn't set the E fuse. Did I somehow messed the numbers up? Would be very funny. DDR has to be 1. IH8 DDR is 1. And then port B is 1. That should give us high output. You know what? I'm gonna comment this out and maybe it will fix something. Make send. Okay. Oh, the loop isn't working. Because now it's high. Okay, yes, that makes way more sense. Why isn't the loop working? Let's split it this way. Key matrix driver. How do I loop? Loop? Do I go back to the loop? R jump, not break. Yeah, this is conditional jump. Yeah, I'm so lost. This has been like half a year since I last worked on this. R jump. Relative jump, yes, not. Make send. So now. Okay, yeah. Toggle. Oh, we do have a toggle. It's pretty fast toggle. Can we get some measurements on the fastiness of this toggle? The fastiness is 4 megahertz. Yeah, that should be the 16 megahertz crystal. Right? We have 1 instruction, 2 instructions, and our jump is 2 instructions, I think. So 1, 2, 3, 4, and 16 megahertz divided by 4 is 4 megahertz. Seems fairly logical to me. So, okay. Now we can go to the PLL. Close this one, we were here. So, clock selection register. Wait. Do we have to select the clock? What's an RC oscillator? Is there an internal 8 megahertz oscillator? Why did I solder on 16? What? Okay, yeah, I don't know. These 2 bits are SOT value for the RC oscillator. Okay, what did we select? External crystal oscillator for some reason. What is the RC one? Is it listed here? Internal. I thought it was like 1 megahertz. Okay. Well, I guess we have a double time CPU now. Great. So clock selection register 0. Selected by the fuse bits are copied into these bits. Okay, so this is just basically to read if the external oscillator is selected by the fuse bits, which it is. The SUT fuse are copied. That's not how you spell copied. This is how you spell copied. Why? Okay, into these bits. The firmware can modify these bits by writing a new value. This value will be used at the next start of the external oscillator or low power. Okay, we can just ignore these. These will be set automatically for us. Here's how I think this works. Now, C bit description. Let's go. The OSCE bit must be written to a logic 1 to enable the external oscillator to disable. So this has to be a 1. So we currently have 1, 2, 4. So currently have... Wait, no, we can't write a 0 to this. We have to actually write something there. These 2 bits are the SUT value of the external. Okay, so we need to find out what the ST is. What kind of value they have. This is 7. So guessing this is all 1 because for some reason everything is inverted. So they both have 1. Okay. Yeah, this. Oh yeah, so it 1 1. Okay, yeah. So we currently have the 0 0 1 1. So we have a 3 and we have a 4. Must be written to logic 1 to enable the. We have 3, 4, and CLKS clock selector. So to select the external oscillator, we must be writing this to a 1. To enable it, we have to write this to a 1. And the SOT bits to stay as a 1 need also be a 1. So we have 3 and 5. Okay, yeah. Clock select 1. Let's see if it's the same in the I'm just gonna comment out of this. So let's start with, you know what, let's start with this one, and whoops, x, what did we say, 3 and 5. Then we're gonna out this, but we're gonna out this to clock select 0. And that should handle the first one. I'm gonna write the quick comment after this so we don't forget. CG bits from fuse and select / enable x Punkt oscillator. Okay. Now, next one. We need to set all 3 of them. Now there are RC clock select for the reset is part of loaded by the 00 that corresponds to the modifying server by female before switching is prohibited. Modifying this value. But can I just modify 1 bit? Like a nibble? Is there something like that? That would be really cool. Add subtract logical and. What can I write into, where's the out bit? Out? Move LD out. Yeah, this goes to an IO address. But can I? Is there something else with IO address? A logical operation or something? No IO. That's not good, not good. Not. Yeah, I don't think I can. Just gonna set them the same value as it's saying here, or I have to like do some weird 1-bit toggle. I don't even know if that's possible. Clock configuration for the RC oscillator. Wait, I could read the bit and okay, I'm just gonna load it with a 2, and that should do the trick. Right? Yeah, probably. This is the interesting one. The reset, if it's selected by the fuse bits, which it is, this part is loaded with the fuse configuration. Right. X clock select. Is it these 4 bits? Yeah, okay, I don't actually need to change it. Seems to do everything automatically here. Okay, clock select 0. Clock select 1. This is not clock select 2. Getting scammed. Or is it just referencing these 4? Yeah, this is weird. Okay. So the pin divider, P in divider, prescaler in okay. Oscillator calibration register. What? It's used to trim the calibrated internal to remove process variations from the oscillator. Okay, this is just for the internal. I don't care about that. Yeah, clock's prescale register. To enable the change of these bits. Only updated when the other are simultaneously written 0. 4 cycles after. So I first have to write 8-0, and then I can and then I can actually write the real value within 4 cycles. Okay. These bits defines between clock source and the internal system clock. These can be written runtime to vary the clock frequency to suit the application requirements. As the divider divides the master clock input to the MCU, the speeds of all synchronous peripherals is reduced when a division factor is used. Given, okay, yes. If this is unprogrammed, clock div 8 is unprogrammed, the bits will be reset to 000. Wait, do I have a... Okay, it is 0. Does that mean it's unprogrammed? Probably. I don't remember programmed is checkmark, unprogrammed is not check, so it is programmed. Okay, we need to unprogram that. So this should be FF. But I get the 4 megahertz on my pin toggle. You know what, we're gonna try again. set this one to 0, 0 again. Yeah, I'm gonna comment this out. Okay. So if I make this, make send. Now this is with the technically still programmed clock select, no, clock divider. Let's see what frequency we get. The frequency is 4 megahertz. Now, if I, guess what has to be FF, right? Yes, the low fuse. And it is already FF. Okay, yeah, never mind. Panic over nothing. Nice one. Hadn't had one in a while. Yeah. And we're gonna comment it out again. Wait, no. Loop can stay. Whoa. That's wacky. And we can delete this. So let's see how it's going further. Okay, so it is the right one because the fuse bits set this, so I don't have to touch it either. Clock division factor. Okay. PLL control and status register. This is what we need. Reserve bits, I'm gonna ignore them. Input prescaler 1, 5. What? What is this? What does it mean? Why is there no explanation? Please. Why is this one only read? What are you doing? These bits allow to configure the PLL input prescaler to generate the 8 MHz input clock for the PLL from either a 8 or 16 MHz input. Seems pretty sensible when using 16 MHz. This bit must be set to 1. The pin diff. It's all. Buddy. It is read only. How do you want me to set this to 1? Sir. Why? What? What is this description? Bit 7 to 5. Yes. You are reserved. Bit 4. yes. Bit 3, yes. Bit 2, yes. Bit 3 to 2. What? Am I blind? Do I just assume this is read-write? I don't know how to measure it if it isn't. When this is set, the PLL is started. Why? Why are you started? What is happening? What is this description? This is when this is started, okay? Note that the calibrated 8 MHz internal resonator is automatically enabled when the PLL is set and pin mux C is set. Is set and with pin mux set, probably without the is. So this has to be enabled also. Do we have a PLA FRQ register? I do not see one. I'm just gonna Control F this shit. There's literally only one match. Is it in the image? Is there a pin mux here? Is it a thing? Does it exist? No. PLL ITM or whatever this is. Aha. This is going to a timer. Timer 1 is this. Is it this one? Timer counter 0. Timer counter 1. This is timer 1. External. Do we have a PLL? Okay, yeah, no, this is. Okay. I'm just gonna yeah, this description doesn't really make a lot of sense. It seems like we need to enable this one. So set this one to 1. Set this to 1 if we want to enable the PLL. clock to the reference clock. And then we wait until this bit is set. PLLE. So the PLL is gonna guess the frequency, the higher one, and so it kind of swings around it until it hits it well enough. And when it's right, when it's at the right frequency, this bit gets set. So we basically, this is the read. I don't know why, but this bit's allow to configure them. I'm just gonna assume this is read write, probably an error. So I'm gonna set this register to 6, and then I'm gonna loop until this one is at set 2. So we're gonna copy this, paste it, 0, 6. Jesus Christ, can I? Okay, thank you. Which one was it? PLLCSR. PLLCSR. Wait, what's the time? I have a clock. Oh, 20 minutes. Let's go. Speed boost. Let us change this one to divide circle 5, 2, comma, and label PL. You have to write comments if you're gonna write assembly, because otherwise it's not gonna work. I know there is an instruction to check for 1 bit. That is a thing that I used it. Can just copy it. Where did I use it? Scan. Okay, here. Oh, sorry. Load all register, check if everything is 0, return if everything 0. Yes. If bit is cleared, skip the next instruction. Yes. This is it. Gonna copy that over here. Gonna paste it. We're gonna do PLL CSR. And we're gonna set, it's supposed to be 0. Yeah. So the next instruction would be to jump up 2 instructions. Right now. Is it? I think I have it somewhere differently. Yes, here. Source. No, not source. Platform, source. Platform. Yes. LED driver. Yeah. So this will jump +2 instructions. I think it will jump to here. I actually don't know. You know what we're gonna do with the easy way? What are we gonna... While not set. Calibrating. And our jump. Calibrating. Okay, this should work. Once it is done, it will get out of the loop, and yeah. Okay, next one. All right, next step. We were here. Configure, enable, check. Yes. Enable USB interface. USB micro enable bit. That sounds like the thing I'm looking for. 8.0 USB con. We're gonna do the whole copy and paste. And 8.0 USB con. Enable USB. That was easy. Configure USB interface. That's not gonna be that easy. So what do we... We have some info on that. Ooh, I'm getting tired. I'm too high. Alright. One endpoint, default control endpoint. Yes, this is the one I want. You know, just basic. I want to send one acknowledge. USB software output enable register. Okay. Allows to enable or disable USB buffers. Direct drive by software. Okay. When direct drive for USB buffers is enabled, the UPDRV values are output to the buffers. UPD, okay, these two are output to the buffers. Direct drive is enabled. I don't know what direct drive is. What is that? We're gonna direct drive enable configuration. Okay, yeah. Still don't know what that is. These bits select the mode of operation of the USB buffers. According to the table, yes. Possible configurations bit allowed to enable or disable USB buffers direct drive by software. Okay, I don't care about them. This bit is read only. The value read from this. The direct drive is I can access the input and output values of the data lines directly via software. Yeah, I don't want that. Are they default 0? They are default 0. Okay, yes. I don't need that, I think. I don't even know what I would need this for. Writing this bit as a logic 1 disables the... Okay, I'm gonna need more info on this. I think I need that. Control F, 3.3. Oh, no. There was one before. 3 IO. Okay. External power supply. Self-powered application with 3 volts. Okay, this next turn I don't have an external. AVC, VCC, UVCC, UCAP. I hope I don't have that connected. It's gonna be a quick check. UCAP. Yeah, I don't have it connected. I am happy. And everything to 5 volts, yes. Wait, no, this one. Okay, yeah, we need this internal regulator enabled. Where is it? Could just, yeah. Disable, this bit disables. Okay, yeah, then we can ignore this one as well. Operating modes. Wait. Okay, this seems like enough configuration. Oh, 8.0. Never mind. Endpoint reset. Wait, what? Reset idle any other state. The endpoint must first be selected. Can then access the various endpoint registers and data. Okay, I first need select the endpoint, activate the endpoint, configure the oh no, this sounds like a tomorrow task. Right now I'm not going to be streaming tomorrow. Yeah, I'm going to do some reading on this. So we need to configure the endpoint direct. But nice to have a flowchart finally. So we need to select endpoint 0, we need to activate endpoint 0, then we need to configure endpoint 0. The fuck is that for a feature not yet disabled? Please don't. I don't want to die. Okay, configure the endpoint size. Okay, so we have, I think, 2 registers we need to configure. That seems doable. Then test it. Okay, and that's a thing. Endpoint activated error. Okay. Okay. Address setup. USB device address is set up according to the USB protocol. The USB device after power up responds to address 0. Yes. The host sends a setup command. The firmware records that address you add and it keeps add enable clear. USB device sends an in command of 0 bytes in 0 length packet to acknowledge the transaction. Yes, this is what I want to get next stream. The acknowledge. The in command without any bytes. I want to see that sent by. Okay, I can't really see that sent by my. Yeah, okay, I just want an answer. Okay, after this is sent, then we can set address enable by setting probably address enable equals to that. And they should not be written at the same time. Skip the hardware after power up reset, when USB reset is received, or when the macro is disabled. Okay, we have like a very slow keyboard, we can freeze it. Remote wake up, stall requests, stall handshake, control endpoint. Okay, yeah, this is how you set up or manage the control. It's always acknowledged. Yeah, okay. That seems like a next stream problem. Yeah. So let's see if this compiles. I should probably write that. Make that. That did not work. Operand out of range. What are you talking about? He was lines 17, 21, and 24. So 24. So it seems to 21, 17, but this one works. 17, 21, and 24. But this one, maybe because there are read bits which it's trying to write. That can't be it. It would just ignore it. Operand out of range. One, 7, 6. 1, 7, 6 to hex B0. Right. I don't have B0. I was talking about the registers. Am I including some wrong register library maybe? Okay, yeah, I'm too tired for this. Yeah. I will maybe look into this, maybe next stream. Next stream we are trying to set up the control endpoint. So we're finally getting some progress. Yeah, so I'd say bye-bye.